Welcome to the Python People podcast, where I'm joined by this week's guest, Alex Milanovic, Head of Data Science for Love Holidays. Alex, welcome. How you doing?
Really good, thanks. Thanks for having me.
No worries. You're very welcome indeed. Very welcome indeed. So, Alex, you, I think, have had a pretty impressive career in data thus far, and now in a pretty big, blue chip, brand that everybody knows and loves. So, yeah, really great to hear a little bit more about your journey today, and how you've arrived into data leadership. So, yeah, talk us through it. Tell us a little bit about your background and how you arrived to where you are.
Yeah, thanks, Guy. So my background, I studied math statistics at the University of Warwick. Didn't really enjoy the theoretical side that much, so started kind of going rogue and discovering other areas that I really enjoyed. I kind of came across artificial intelligence and TensorFlow, I think 2016. It just maybe come out of beta at that point. It's quite new.
Yeah.
And then I was really interested in the crypto space and just started kind of building in that area and sort of eventually spun out a startup out of a project I was building, got a nice team together. But then the sort of crypto market crashed in 2018 and the startup kind of went along with it.
Right.
But that was all good. Had a sort of full-time job lined up afterwards. A company called Tracer, building a diamond industry traceability platform. That was really, really cool. Sort of working with lots of 3D data, images, videos, all sorts of types of data that any data scientist would sort of love to get their hands on. And then through that, eventually got the chance to lead the data science team, which was a really amazing experience. Had a super talented, very diverse team, just working on really, really cool projects. And then after that, I sort of fancied a change, and that's when I sort of came across Love Holidays, and currently leading their data science team. Again, really, really talented team, building some amazing things. Really cool company, working with tons of data, lots of different problems, and the travel space is really, really interesting too.
Yeah, I can imagine. Absolutely. So it seems like you've had a really well-rounded career so far in as far as the entrepreneurial part of doing a startup, and then obviously joining a much bigger kind of enterprise. So talk us through, what would you say are some of the most valuable qualities that you feel you've learned throughout your journey as a data leader?
Yeah, I'd say like one of the most important things I try to build with my team is really deep trust with them. I think I need them to trust me, and I need to trust them to be able to deliver what they're sort of planning to deliver.
And how do you go about ensuring that you build that trust? Do you sort of have a particular approach and you sort of book in regular structured sessions to communicate, or how do you go about it as a leader?
Yeah, I think one-on-ones are really, really important. Just sort of giving the space for people to sort of voice any concerns. I think in one-on-ones, if you're talking more than your team member, then you're probably doing it wrong. I think you
Yeah.
want to make sure that they can get what they need to get off their chest, and just trying to give them the right support, but also don't try and hold people's hand too much. I think I found in the past where maybe quite a junior data scientist was maybe struggling on a project, and because I was busy in meetings, I didn't get the chance to respond to them and sort of help, and they ended up just figuring out on them on their own, and that was really, really nice to see. I wouldn't say I started doing that deliberately, but I would sort of let them sort of struggle a little bit, and then they would sort of I would see how much they would grow from that process and just figuring things out themselves. That's how I've always sort of taught myself, even though I studied math statistics. There was not so much computer science in there. I had to sort of learn it myself, and I think now with AI, there's almost no excuse for not being able to learn a new concept. It's easier than ever to learn things. But at the same time, I guess the types of skills that you need to learn things are quite different. There's a very different way of learning now.
Yeah, very much so. Absolutely. And I mean, how do you feel, I suppose, from when we started True North back in 2019 to where we are today? Bearing in mind we've always pretty much focused on the data science and machine learning market. It's such an inherently different space now, and I guess that evolution that's taken place over the last 2-3 years, it's really changed the landscape, to the degree that the skill sets required probably back then. Yeah, okay, there's some similarities, but there's definitely different approaches and different attributes that people look for. So, how do you feel about that now, insofar as I suppose some of the characteristics and attributes that you potentially look for people when you're hiring into your team, bearing in mind the evolution of AI, do you feel that shifted the paradigm slightly insofar as what you look for in somebody?
Yeah, I think to some extent, I think a big role of a data scientist is now doing a lot more engineering than before. I think a lot of interacting with LLM services, and sort of deploying models to production. I think that's more on the engineering side. And I think that's something we definitely look for whenever we're hiring at Love Holidays, and also in previous roles as well. That's just something we have to test for. I think if you get a data scientist who answers an interview question saying, "Oh, I don't really deploy things to production. Someone else does it on another team. I have no idea how it works," I kind of see that as a bit of a red flag. It shows that they don't have curiosity on how that works, and they maybe won't have the skill sets to pick that up. But yeah, I'd say that that's quite a big shift, and I think there's a very different way of thinking between the way data scientists think and the way engineers think, and
Yeah.
typically when you merge them together into one team, that there tends to be a bit of friction. I think the data scientists communicate in their own language, and engineers sort of communicate in their own language, and it's difficult to bridge that gap.
Yeah, absolutely. I guess the times of sort of building models in a vacuum seem to be kind of coming to an end, don't they? And it's very much about, let's say, embracing the engineering piece now and understanding the the MLOps piece, I suppose, and deployment of that. Absolutely, yeah, we've certainly seen that shift as well from a skill set perspective in the market.
Yeah, and another thing I see a lot is because data scientists maybe not as sort of used to the engineering, they end up building fairly sort of suboptimal models from a throughput and performance perspective. And a lot of machine learning engineers do the same thing, and it's something we're seeing a lot where GPUs are not being fully utilized, and you're leaving performance on the table and incurring extra costs for no reason.
Yeah.
It's something I've thought about for a while in terms of how we can solve that in an automated way, but there don't seem to be that many good solutions out there.
Yeah, well, I guess that kind of leads us on to the next point, and really kind of the crux of the conversation that we were hoping to have today, because we were talking in our last coffee catch up around the evolution of AI and the implications that it has from a sustainability perspective, and in particular things like energy consumption, and talking about GPUs and hardware and that kind of thing. Sort of I think it'd be a good place to start. But talk us through what are your thoughts, I suppose, in the recent evolution of AI and the impact that it's having from a sustainability point of view.
Yeah, I'm sort of super passionate about making sure that compute is as sustainable as possible. It's something that's sort of really important to me. Growing up and going back to Bosnia, for example, and seeing the impact that factories have on climate change, and not being able to breathe the air in certain cities because places are getting quite polluted. So from a young age, sort of seeing the impact of climate change a little bit has kind of motivated me to kind of think about this a bit more. And obviously, I love the area of AI. I love high performance computing using very powerful GPUs, but there's the ugly side to that, which is they require a lot of energy.
Yeah.
And most of our power grid is not renewable, is not powered by renewables. And now with the explosion of AI, there's so much more demand for compute and energy that it's just putting a massive strain on the power grid. I think at the moment the US, their energy composition, about 4% goes towards data centers, and more than half of the US grid is not powered by renewables. And projections show that by 2030 that's going to climb to over 10% potentially. So it's growing very, very rapidly. I think companies are going crazy to build data centers as fast as they possibly can, and there's just no concern for where that power comes from, really. And it affects local communities as well. I think some areas in Ireland, about 20+% of the energy demand comes from these big data centers that are being built. And then the other side of it is the water consumption. You potentially have tens of millions of liters that are potentially used per day by one of these data centers, and that's enough to provide water to tens of thousands of homes. And I think estimates show that every time you make a single prompt to ChatGPT, around 100 tokens or 100 words or so, you use about half a bottle of water. So every time, you do that, just sort of, kind of keep that in mind, and maybe a Google search might be easier for some things, and just might be more efficient.
Yeah, it's really sobering, isn't it? And I think it's something that I guess the adoption of AI globally, it's certainly been, the first time I've seen a technology been truly adopted globally. And I guess that's fantastic in many ways, but obviously it comes with so much other kind of collateral that you just don't really think about. And I think it's good to have this kind of conversation, because I don't think many people really do give it any kind of credence, or really probably understand, the level of processing power that actually goes into it. And I think it is rather sobering thought that we're sort of talking about those numbers already. I mean, I read the other day that apparently already globally it's potentially up to 1% of energy consumption globally is focused on processing AI. And that's, as I said, from what's happened in the blink of an eye in literally kind of the last couple of years, it doesn't feel like it's particularly sustainable, right? And so far,
seeing the rate of growth is insane. I think OpenAI didn't anticipate the level of growth that they would have expected. I think they obviously try to factor that into their planning for capacity, but they've even openly admitted that they've had to pull capacity away from their training infrastructure to focus on the serving infrastructure. They just didn't predict that unprecedented demand.
Yeah, absolutely. So what sort of alternatives do you see that exist out there in the market, and yeah, what solutions do you feel there are to this issue from a sustainability perspective?
Yeah, there are a few companies doing quite interesting things. I think there's sort of two main technologies that seem quite promising. I think the first one is nuclear. Obviously, nuclear is green. It comes with negative connotations, but it is green energy. There's no carbon being emitted as part of that process. There are lots of companies that are building small nuclear reactors, and they can potentially be deployed near these big data centers. So that's a very promising technology. Sam Altman, I think, is investing in sort of nuclear technology. He can see it's a big potential piece of the puzzle.
Mm.
Solar and wind are great, but the problem is they don't, the sun doesn't shine all day, the wind doesn't always blow, so it requires lots of battery technology, which is tricky. But there's one other promising technology, which is hydrogen fuel cells, and the EU has invested over 350 billion euros into hydrogen fuel cell technology last year. And the way it works is you just take hydrogen, and through a process of separating the electrons from the protons, you get energy and some water and a bit of heat. So it's completely green, and it's very, very safe. And a lot of big companies, Amazon, Google, and so on, are building data centers with proof of concepts with hydrogen fuel cells. So it
Interesting.
seems very, very, very promising. The downside is most hydrogen is not produced by green energy. So that's sort of the brown and gray hydrogen that they're mostly created with fossil fuels. So
Mm.
you create hydrogen by separating the hydrogen and oxygen molecules from water, and that requires electricity. So if that's powered by renewables, that's great, but for the most part, it's not.
I see. Yeah, it's a bit like the argument about wind turbines, isn't it? That the concrete used in terms of how that's created to actually anchor the wind turbine offsets very much a lot of the the ongoing benefit that it makes. But I suppose that's all part of the jigsaw puzzle, isn't it? But no, the carbon footprint element is it's huge, isn't it? I read a study from the University of Massachusetts recently that mentioned that a single AI model could produce as much carbon as 5 cars over their lifetime.
Wow.
Which is pretty crazy, isn't it? And I think it's it does start a lot of the responsibility, I guess. Well, not the problem, but this conversation started with a lot of the big tech companies obviously embracing AI, and I think the solution definitely, it feels to me like, rests in their hands. A lot of these big players have to be more responsible about it and be seen to be doing as much as they can. And I heard that Google apparently are kind of trying to offset. We're trying to get sort of carbon neutrality by basically offsetting it against other purchases, more green purchases, and that kind of thing, which is encouraging to hear. But what are your thoughts on the actual kind of, you mentioned the fuel source itself, and that's obviously a big part of it with hydrogen and nuclear and that kind of thing. But what about with regards to the actual hardware piece, so things like AI accelerators and TPUs versus GPUs and that kind of thing? What sort of impact do you think that could have?
Yeah, I think it definitely plays a big piece, and it kind of goes back to the point before I made about really optimizing the usage of your hardware. If you're deploying on a really powerful GPU and you're barely utilizing it, I think that's definitely a problem. I think for the bigger labs like OpenAI and Meta, they're obviously very conscious of this. They're very cost conscious, so I think they will be running their infrastructure in a very optimal way. I think it's more everyone else, and all the numbers do add up. I think if you add all of the sort of AI usage on GCP, on their GPUs, it won't be reaching 100% utilization. I think TPUs, HPUs, and sort of the other alternative compute units, I think, are very, very promising. I think there's a lot of money going into the development, and it's still fairly early. I think it's that they're not generally available in a lot of places. And I think a lot of the sort of bigger AI labs definitely have an advantage because they do have obviously that additional purchasing power, and they're able to leverage those a bit more than most people will be able to. I think TPUs are good because they're generally available. But there's a company called Cerebrus in the US, and they're building wafer scale compute. So rather than a single GPU, which might be sort of 600 square millimeters, they're building a single chip that's sort of 20 times larger, has 20 times more memory available to it. It's massive, has a massive power requirement, but might be more efficient. And they've shown some really interesting benchmarks where they can run AI inference, tens to, potentially even 100 times faster than some other devices. But again, they're not generally available to most people. They're probably hard to work with. They require complex SDKs. But it's a space I'm watching quite closely because I think it's super, super interesting.
Yeah, absolutely. Yes, it's credible to hear those kind of numbers. And you kind of hope it's a situation a little bit, like necessity drives invention, don't you? And obviously we're looking at the problem and we're kind of coming up with a solution in lockstep. But
Yeah.
aside from the hardware piece, what are your thoughts on techniques around the actual building of the models itself, like kind of pruning and distillation, things like that, to kind of shrink the model size and reduce the level of energy required for processing?
Yeah, I think they're very promising, and it's something that whenever we build LLMs at Life Holidays, we employ as many techniques as we can. We have very sort of strong engineering principles that we like to follow. We deploy quite a few LLMs, more than I initially wanted to. I kind of wanted to go for a simpler, more traditional sort of machine learning approach, but they end up working quite well in images at the moment, so we ended up using them. Um, I think the other piece that's quite important is sort of considering, can you use smaller models for sort of tasks that work well, and doing things like fine tuning. I think typically people say, and that's something I've already observed as well, is a fine tuned smaller model often work better than a large sort of general model that's not fine tuned to your specific task.
Yeah.
So I think that's something that people don't use as much. It's a bit difficult to fine tune an LLM. I think there are services that make it easier, but it's something that's definitely worth considering.
Yeah, absolutely. I mean, again, the thing I'm encouraged by is the more you kind of read into it, the more it feels like there is, a lot of active investment into solving the problem. And it's nice that it feels like we can kind of approach it from multiple different ways. And you kind of hope that because of the speed of which it's evolving, the speed of which we can kind of share the information to tackle the problem, should hopefully help, because it feels like, we're certainly never going to go back from the place where we are now with the, how we're embracing AI globally. So we kind of need to fix it, right?
Yeah.
Yeah, very, very interesting. What are your thoughts on other sort of considerations around as the AI industry evolves? You mentioned sort of data centers earlier, and I think that's a really important part. Just again, probably one of those things that people most don't consider when they're thinking about the use of AI. But yeah, talk to us a little bit about the kind of implications involved in the speed of which we're building physical data centers at the moment.
So yeah, I think one of the considerations is the amount of time it takes to build these data centers. It can take years to get permission. You can obviously try and shortcut things as much as you possibly can. There are some startups in America that are building data centers very rapidly, and they're potentially building smaller data centers and letting them scale a bit more. But then there's another consideration around the backup generators that are required. If the power grid has issues, you need these data centers to still be available. So unfortunately, they have sort of diesel and gas generators on site. There's currently not that many ways of sort of providing the amount of massive power they need using renewables, but that might be solved in the future. And so it takes a really, really long time. And then I think one of the concerns of a lot of people is, by the time they're built in, say, 2, 3, 4, 5+ years, are we still going to have that massive need, or will models become much more efficient? We obviously saw how DeepSeek was able to create similar performance to leading LLMs out there with far less compute. I think that's sort of a whole other area where you might argue that the reason they were able to sort of become quite successful in terms of their models, they use a lot of data from OpenAI, and they sort of use that distillation. But that's a whole sort of separate piece. But it is something that I do sort of think about, is, are we going to need all this compute in sort of 2 years' time? Obviously, lots of people say, if we want to build AGI, we have to put as much resource into it as we possibly can, which makes sense. But we're starting to see a bit of a plateau in the performance of models. I think GPT-5 was touted to be this massive model that could solve all the world's problems, and it was pretty overhyped, I would say. And its performance, sure, it is better, and benchmarks show it's better, but it's not an order of magnitude better the same way that GPT-4 was over 3.5. So
Yes, yeah,
I would say we're starting to see a bit of a plateau, and I think lots of smaller models are starting to emerge, and those models are typically a lot more efficient.
yeah.
And there's lots of distillation techniques you can use to learn from the bigger models. So, yeah.
Yeah, I think it's a great point. I mean, talking about the physical, the commitment to building those physical data centers, and like you said, because there's, the speed of which things are evolving, it's kind of going to create this friction, I think, between committing to the energy, the resources, the money to actually build these things versus, like I say, really predicting where we're going to be 2, 3 years down the time. It's a real balancing act, isn't it? To get right.
Yeah, for sure.
I think the point you mentioned there is we sort of progress towards, I suppose we use the term AI quite loosely.
Mm.
Generally speaking, in this day and age, I guess we're talking mainly about LLMs, right?
Yeah.
But you kind of use the term AGI there, and I guess just to clarify, we're talking about actual general intelligence.
Yeah.
And you know, I find that topic fascinating because, you know, when I guess AI was first coined, it was really thinking about that AGI piece where we were trying to replicate human thought. And you know, I did a podcast a while ago with a chap who focused on cognitive AI versus you know, kind of traditional, well, not traditional, but the more Gen AI that we all know and talk about today. But
Yeah.
just interested to get your thoughts on where we are in today's world with our use of LLMs and that kind of thing. What do you feel needs to happen, and how do things need to evolve to reach a point of AGI, if that makes sense? And, you know, what would you expect to see at that point, you know, above and beyond maybe more of a further evolution of the you know, chat GPT, you know?
Yeah, it's a good question. I think it's hard to define what AGI is. I think everyone has their own definition. Like if you say take a Turing test, I'm pretty sure the latest version of ChatGPT would sort of pass that with flying colors. I think that would be fine. I think the reason we're maybe reluctant to call it AGI right now is because of all of the really simple questions it trips over. I think if you use it for coding, I mean, I use, you know, Cursor pretty much on a daily basis, and you just see it. Yes, it does do things in a fairly, you know, quick way, and it can build things that make sense and they work. But then when you start to, you know, really assess the solution it's come up with, it's overcomplicated things. It's added way too many comments, and it's you know, creating things that are not as maintainable, have security flaws. And you think, if this is, you know, genuinely super intelligent, then why is it coming up with all these issues? So I don't think we're there yet. And yes, progress has evolved very, very quickly, and I don't want to sort of doubt that progress too much. But I don't think it's something that will happen in the next few years. I think there's still a lot of research, and I think there's fundamentally probably a plateau that we'll hit with a transformer-based architecture.
Yeah.
I think there are lots of companies that are experimenting with other potential architectures. I'm not as familiar with exactly what they are, but I was just doing a bit of reading about them. I think it's similar to how in the past there's only so much you can do with an LSTM architecture. You can use it for some time series forecasting, and technically you could use it to generate text. I think when I was at university, I think I was probably bored, and I wrote a Python script to generate some Shakespeare using an LSTM. And you start reading it, and you think, oh, okay, these are words that you know come together, and you can almost read them, but then they don't have any actual meaning, and the LSTM is not capable of capturing that sort of nuance that we have in language. But transformers can do that really, really well. But I think there's a limit of probably what transformers can do, and there'll probably be another architecture that comes out. And it's just insane to me that it's all just linear algebra below the hood. And you can maybe say that about, you know, neurons in a brain. They're just sort of interconnected. They wire, and they, you know, they fire together.
Yeah.
And there's sort of not, quote unquote, not much to it, but there probably is so much that we don't understand.
Yeah.
And I think there'll be something else that will come out potentially that will revolutionize things, but it's just so uncertain. There's no way of telling.
Absolutely. It's a really kind of hypothetical question. I appreciate it. Put you on the spot there, but I think that's such a great answer. And I agree. It kind of feels like there has to be a shift or an evolution in the architecture, because transformer-based architecture to date, you know, okay, yes, it works. And this is the first time, say, with LLMs and so on and so forth, that we've seen something that feels incredibly powerful. But to your point, if we're really trying to replicate, you know, neurons and that kind of thing, you know, it's obviously a very limited architecture that can't do that. And it's, you know, to me, one of the things I found most interesting, I did biopsychology at university, and one of the things I found interesting is like the plasticity of the brain and how it adapts and changes depending on its external surroundings and external environment. And I feel that's the piece that we need to evolve to get to that place of AGI, is a form of kind of self-fulfilling model training, or which obviously is quite scary when you start thinking about those words and saying them outright. But
I think you've described reinforcement learning to some extent, and that is used in some LLMs. But I think reinforcement learning is a really sort of tricky area to get right. We do use it quite a lot in a lot of holidays where we can, but our models are just notoriously difficult to get them to converge, and there's not as much research as there is in, say, the computer vision space, so that's been fairly well understood for quite a long time. But yeah, there could be some more advanced types of reinforcement learning that might come out that will power, even more powerful LLMs in the future. I definitely see that as being a possibility.
Yeah, absolutely, absolutely. Well, it's really, really great conversation to have, I think, and a lot of food for thought on other areas that maybe you don't necessarily, say, think about when we're thinking about day-to-day use of AI. So I really, appreciate you coming and having a chat with us today. But I like to ask every guest the same question, if you would care to indulge me, at the end of the episode, and that is, what would you say has been your one favorite piece of advice that you've received throughout your career or your personal life, but that's stuck with you for the journey?
I can't actually remember who sort of instilled this in me, or whether it's something that I kind of came across, maybe in a YouTube video, whatever it might have been. But there's a mentality I've always tried to have of just going for a task and sort of almost underestimating how much work it will be, and just figuring it out and doing it anyway. I think it's something you have to do, say, when you're running a startup. When I ran my first one, I kind of jumped into it, didn't realize how much work it would be. Thought, oh, this is fun. Let me just go for it anyway, and you just figure it out along the way.
Mm.
And I think a lot of people might shy away from problems. They think it's, oh, this is too difficult. And I hear a lot of things from some data scientists who will say, oh, this is not sort of my area of expertise. I don't really want to, touch that. I'm worried about breaking it. And I'd say just go for it, and just figure it out, have confidence in your abilities. And again, nowadays, talking about AI, you almost have no excuse. You just can interact with an LLM and figure things out, and things won't be perfect and it will be difficult. But yeah, I think that's just the main thing. Just going for things and just having a naive optimism about the world.
Yeah, I think that's such a great piece of advice, to be honest. I think something that, if we're able to install in the next generation, it's certainly something I'd love to install in my kids, that, just take yourself on and give it a go, because I think inherently as people, there's a natural pessimism there. It's the fear of the unknown, if we've never done it before. But if you can really exercise that muscle of just problem solving and throw yourself into any solution, worst case scenario is you kind of learn how to do something.
Yeah, you really have to frame it that way. I think if you're worried of making mistakes, that's not the problem. Is you have to just make sure that you can learn from them, and just have a really positive attitude towards it, and you have to really reframe the way you think for that.
Absolutely. Well, Alex, so thank you for coming in and having a chat with us. Really enjoyed the conversation. Definitely a lot of value shared, and a lot of food for thought to process. But no, I'd love to have you back at some point in the future when the next breakthrough comes in, probably next week.
Yeah,
And we can talk about that. But no, thanks again for coming in, and wish you all the very best with your I see things are in very safe hands at Love Holidays, and do come back and have another chat with us at some point in future, please.
Yeah, thank you so much for having me. Would love to be back. So thanks.
Great.